Now we've learned what acceleration is and how we get it off a velocity time graph. Let's look at it in a little more depth and consider different cases. We said that the gradient of a VT graph is delta V over delta T, and that is equal to the acceleration. Since velocity is a vector, and I add or subtract them, that means acceleration is a vector. We know that if we have a coordinate system and an object is located here, we would say its position is positive. If it is located over here, we would say its position is negative. And that if we were to move from here to here, the displacement would be positive. We would have changed in a positive direction. It also means that the velocity will be positive because it's the direction that the displacement is changing. Conversely, if we move from here to here, the displacement would be negative because we're changing in a negative direction, and our velocity would be negative. So the question becomes, what does a positive acceleration or a negative acceleration mean? Let us first consider a case where we have an object that is here, traveling at, say, 1. Its velocity is 1. And then it's going to 2, and it's going to 3, and it's going to 4, like so. We can see it's getting faster. Well, acceleration is delta V over delta T, and it's a vector. And delta V is final velocity minus initial velocity over the change in time. So if we were to imagine that each one of these occurred over 1 second, each of these changes, our final velocity is 4, and our initial velocity was 1, and it occurred over, let's say, 1, 2, 3, 4 seconds. So we now have 3/4, or 0.75 meters per second squared. Notice the sign of it is positive. In this particular case, it is getting faster in the positive direction. The acceleration is positive. It's getting faster in the positive direction, so its acceleration is positive. The definition of the direction of acceleration is the direction that the object is getting faster. Let us consider the reverse. Let us suppose we are here, like this, traveling in this direction, and we have a velocity of -1, and then -2, and then -3, and then -4, like so. Well, then our acceleration would be delta V over delta T, which is -4, our final velocity, minus a -1, our original velocity, initial velocity. We are headed in the negative direction. And the time, again, 3 seconds. Now what we have is a situation where we have -4 minus a -1 gives us -3, actually this should have been 4, -3 over 4. -3/4, and we get an acceleration that is -0.75 meters per second squared. Notice the only difference between the burgundy case and the blue case is the direction. The direction of motion, but the direction they're getting faster. This acceleration was negative. The negative didn't mean it was slowing down. This blue course was speeding up, and it was speeding up in a negative direction. Similarly, the burgundy was speeding up in a positive direction. So the sign of acceleration indicates the direction the object is getting faster. Now at this point, students will often ask, what about deceleration? What's deceleration? It turns out deceleration, there's no real need for this word. There's no need for this word any more than there is a need for a word for negative velocity. We can have positive velocity and negative velocity. It's just the velocity. We don't need a special word for different cases of acceleration. We can just describe which direction is positive or negative. But let me show you the technical meaning of what deceleration is. We examined two cases on the previous slide. Let us suppose now that the person is starting out at 4 meters per second, 3 meters per second, 2 meters per second, and 1 meters per second. So you can see as they're moving in the positive direction, they are slowing down. Then we would have an acceleration our final velocity is 1, our initial velocity is 4. We have negative 3/4 meters per second squared, 0.75 meters per second squared. Negative. In this case, in the positive direction, we're getting slower. So one could imagine then, or argue that we're getting slower in the negative direction. Now the reason that things change speed is forces. It's much easier to think of this in terms of forces. If you were a force pushing on this object, which direction would you be pushing? You would be pushing in this direction, negative. The acceleration is negative because the force that's causing the acceleration is negative. This is a case of deceleration. We have velocity, which is positive, and acceleration is negative. That's the technical definition of what deceleration is, when the directions of the velocity and accelerations are opposite. So let's consider a second case over here. Let's do the same numbers. So we have positive 4, positive 3, 2, and 1 meters per second. You can see that the numbers will be exactly the same. Our final velocity is 1 meter per second. Our initial is 4 over 4 seconds. It will be negative 0.75. Doesn't matter where we are on the number line. Our velocity is positive. Our acceleration is in the opposite direction, or negative direction, because the force that would be applied to cause that is pointing in the negative direction. Now let us consider this a little bit differently yet again. Let us start down here, and we will have a 4 meters per second, negative 4, negative 3, negative 2, and negative 1 meters per second. So let's calculate the acceleration there. The acceleration is Vf minus V0 over delta t. Final velocity is minus 1 minus a negative 4, which was the initial, all over 4 seconds. So now you can see we have positive 3/4. We had negative velocities, but the acceleration is positive. Why? It is slowing down in the negative direction. The force that would cause that push is in the positive direction. And you can see then that if we did the same thing over here, we would get the same result. We would have acceleration and velocities in opposite directions, and we would again have positive 0.75 meters per second squared.